If energy can't be created or destroyed, where did all the energy in the universe come from? It's a mystery, but let's break down the types of energy. Energy is the capacity to do work. Simple definition, right? But behind that simplicity lies the entire machinery of the universe. It's measured in joules, and it's everywhere, from the sun above to the sandwich in your hand. There are several forms of energy. Let's start with potential energy. Potential energy is defined as the stored energy due to the position of an object. Gravitational potential energy, GPE, is the potential energy of an object due to the height of an object from the ground. An example of potential energy is water behind a dam. The water stored at a height in a reservoir has gravitational potential energy. When released, it flows down and can be used to generate electricity in a hydroelectric power plant. The object at the surface of the Earth has 0 GPE. The higher the object from the Earth's surface, the greater its GPE. Here's a scientific fact. The Hoover Dam holds enough potential energy to power a city for months. The formula for calculating GPE is GPE is equal to mgh, where GPE is gravitational potential energy in joules, m is mass in kg, h is height in meters, and g is gravity, which is equal to 10 meters per second squared. The other form of energy is kinetic energy. Kinetic energy is the energy possessed by an object in motion. An example of kinetic energy is the speeding car. When a car is driving at a high speed on a highway, it possesses a large amount of kinetic energy. Kinetic energy depends on the mass and velocity of an object. The formula for calculating kinetic energy is Ke is equal to half mv squared, where Ke is kinetic energy in joules, m is mass in kg, and v is velocity in meters per second. Here's a quick challenge. If a 2 kg ball is moving at 3 meters per second, what's its kinetic energy? Type your answer in the comments. The other form of energy is electrical energy. Electrical energy is the energy caused by the movement of electrons. Try this at home. Rub a balloon on your hair. That's static electricity, tiny electrons dancing around your head. Electrical energy is a form of kinetic energy due to the flow of electric charge. An example of electrical energy is a power plant. Power plants convert various forms of energy such as kinetic energy from wind turbines or thermal energy from burning coal into electrical energy, which is then transmitted through power lines to homes and businesses. The other form of energy is thermal energy. Thermal energy is the energy due to moving particles in an object. An example of thermal energy is boiling water. When water is heated on a stove, it absorbs thermal energy, causing the water molecules to move faster and eventually transition to steam. The other form of energy is chemical energy. Chemical energy is energy stored in the bonds of chemical compounds. It is released or absorbed during chemical reactions. Here's a mnemonic tip. Chemicals bond, then respond. An example of chemical energy is gasoline. Gasoline contains chemical energy stored in the bonds of hydrocarbon molecules. When combusted in an engine, this energy is converted into mechanical energy, powering vehicles. The other form is nuclear energy. Nuclear energy is the energy stored in the nucleus of an atom. It can be released through nuclear reactions such as fission or fusion. An example of nuclear energy is a nuclear reactor. A nuclear reactor uses the process of nuclear fission to split atomic nuclei, releasing a tremendous amount of energy, which is used to generate electricity. The other form is radiant energy. Radiant energy is the energy of electromagnetic waves. It includes visible light, radio waves, X-rays, and others. Examples of radiant energy include solar panels and microwaves. Solar panels convert radiant energy from the sun into electrical energy through photovoltaic cells. The other form is sound energy. Sound energy is the energy carried by sound waves which are produced when an object vibrates. Examples in loudspeakers and musical instruments. A loudspeaker converts electrical signals into sound energy, which we perceive as music or other audio content. Now, the law of conservation of energy. The law of conservation of energy states that energy can be changed from one form to another, but cannot be created or destroyed. The total energy in an isolated system remains constant over time. Suppose an object is lifted to height h. Its gravitational potential energy is equal to mgh. Before the ball falls, it has gravitational potential energy due to height, and zero kinetic energy as it is not moving. When the object is released and falls, its gravitational potential energy is changed to kinetic energy. At the midpoint, the gravitational potential energy decreases by half due to a decrease in height, while kinetic energy increases due to the increase in speed. At that point, the gravitational potential energy to the kinetic energy. Just before hitting the ground, all the gravitational potential energy is converted to kinetic energy. Another cool example, a pendulum. As a pendulum swings, its energy continually transforms between kinetic energy and gravitational potential energy. At the highest points, the energy is mostly potential, and at the lowest point, it is mostly kinetic. The total energy remains constant if we neglect air resistance and friction. Finally, the sources of energy. There are renewable sources and non-renewable sources. Renewable sources are sources that can be reused or replaced. Examples of renewable sources include the sun, which radiates thermal and radiant energy, the wind, which can be used to generate electricity by converting the kinetic energy of the wind into electrical energy, water, which can be used to generate electricity by the conversion of the potential energy of water into kinetic energy and then to electrical energy, geothermal, which is the heat energy stored inside the earth and can be used to produce electrical energy, and biomass, which is energy from organic materials. It can be used to generate electricity by the conversion of chemical energy stored in these materials. Non-renewable sources are sources that cannot be replaced once used. Examples include fossil fuel, coal, natural gas, and nuclear energy. To recap, energy is defined as the capacity to do work. There are several forms of energy. Potential energy is the stored energy due to the position of an object. Kinetic energy is the energy possessed by an object in motion. Electrical energy is the energy caused by the movement of electrons. Thermal energy is the energy due to moving particles in an object. Chemical energy is energy stored in the bonds of chemical compounds. Nuclear energy is the energy stored in the nucleus of an atom. Radiant energy is the energy of electromagnetic waves. The law of conservation of energy states that energy can be changed from one form to another, but cannot be created or destroyed. The total energy in an isolated system remains constant over time. Energy is everywhere, but it never vanishes. It just changes clothes, and that's the secret rhythm of the universe. Now that you've unlocked the forms and flow of energy, get ready. Next up, we tackle power, how fast energy gets things done. Stay tuned, stay curious.